Hello, this is Dr. Tom Gerard, and I wanted to meet with you today uh, via video to go over some things about the course that's going to go forward. I want to talk a little bit about your final project for the course. Now, the final project is really a research project that you're going to have to conduct and gather data to to conduct. So I wanted you to begin to start thinking about it and working on it right away. So the way this course was originally set up by the previous professor was to have a project for each of the modules. And as you know, I have only had one project, which was in Module 1 for the Excel histogram that you were supposed to create. The other Module 2, there was no project. And Module 3, I really want you to start working on your final project because it's not going to be something that you're going to be able to do the last week of school. I want you to start thinking about working on it right now, and it is an actual research project. So I'm meeting here in a classroom so I can write some things on the board if I need to. But I want you to be able to um, think about this. So we started talking in chapters 8 and 9 about sampling. Chapter 8 went a little bit into different types of samples. This is not a sampling class. It's just an idea of learning the process that you go through to do research. So the first thing in that is to identify the population that you want to study. So remember, a sample, why are we wanting to do a sample? Why do we do research? Why do we do statistics? It's because we want to know something about a population. And the way we learn about a population is taking samples from that population. Now, when we talked about chapter 8, where we were looking at a known population mean, for example, let's say the normal blood pressure is 120/80, the normal temperature is 98.6, and when you go to the doctor office, what they do is they take your blood pressure and your temperature to see if you have a fever or if your blood pressure is abnormal. So somebody's decided that these numbers are what represents the normal population parameter. And so when you go in and they take your temperature, they're taking a sample off of one specific person. And that's what we talked about really before we started talking about sampling distributions, where we were looking at one individual score, like in chapter 7. We were looking at one person or one score compared to the population norm or the population mean. And remember, all of these formulas are differences. Now I'm going to try to do this the best I can. Let me come back here and share this. So chapter 8 introduces the idea of sampling distributions. I'd like to be able to write this on the board, and maybe if I will if I get to a chance. But one of the things I want you to be aware of, and this is, we see this a lot in this course, is that you talk about means and standard deviations, and they're represented by different symbols. Really, these mean the same thing. This is an average or mean of a sample, and this is the mean or what we would consider the standard score in a population. So this would be my 180/20. This mean could be my blood pressure, right? Or my temperature if I have a high fever or something, right? And so all of those formulas that you've seen going so far have to do with looking at the differences between what is normal. So let me come to this slide. So here's our z-score formula that we looked at. And here you'll see it's the mean of my temperature or my score compared to the population mean, right? So z-score formula for population mean is what we looked at in the past, where we might have one average of my blood pressure compared to the normal blood pressure. Going forward now, what we're going to talk about is samples. And if I was going to take multiple samples, so when I get to wanting to make estimates about the population, And you hear that a lot in this particular chapter when it talks about point estimator. A point estimator is the single value calculated from the sample intended to be a true to be close to the true population value. This is where I'm trying to estimate what the population looks like based upon samples. Now, and so quite simply, the sample mean is an unbiased estimator of the population mean, the proportion, and the standard deviation from the samples. Now, the central limit theorem says the more samples we take, the more likely we are to look at what the real population is. So really what I wanted to introduce though here was this idea of what we're interested in is the differences, right? I'm trying to find my formula again. Anyway, so what I want you to be thinking about for your research is you want this to be easy for you to get through for this course. Now, I know a lot of people want to study advanced things and you want to change the world, and that's wonderful. And I encourage you to do that after you graduate and you go to graduate school. But for right now, let's just focus on getting through the class. So I'm going to give you a couple tips. So a couple tips are, you can use nominal data. Remember back in chapter 1 or 2, we talked about different levels of data. We have to have ratio, interval or ratio data to calculate a mean and a standard deviation on. In other words, I can't calculate a mean of the types of apples. If I'm going to have a Macintosh, or Golden Delicious or Red Delicious, I can't calculate means on that. I have to have numbers, like maybe it's the diameter of the apple, so many centimeters and of this kind of apple compared to the centimeters of that kind of apple. That I can calculate numbers on, but I can't calculate on nominal data. Now, so I'm going to use an example, and I'm going to try to write it here on the board so you can see to try to help you. Now, the other thing is, now by the way, this page is in your MyRSU under course resources under projects, and that's this paper that describes it. And the first thing it says is identify a population that you want to study. So you're thinking about, who am I going to study? I'm going to give you an example in a minute. Identify the sampling method, and that was what you see in there towards the end of chapter 8. Don't get fancy about having random samples. Ideally in real research you want random samples. Example, I want to learn about all the students at RSU who's registered at RSU. I want to, that's my population I want to understand. Now I can take random samples. I can go around campus. I can call people that are online students, and I can get data randomly. It would most likely be almost impossible to get data unless I just have years to do work on it for every single student. So I take samples, right? And that's what a sampling distribution is. Say I'm going to take a sample of 25 students today, 25 students tomorrow, 25 different students the next day, and every one of those samples has a mean and a standard deviation. And those means and standard deviations make up the sampling distribution. And so once I have all of those samples, and each of those samples have a mean and a standard deviation, then I can calculate what we kind of call the mean of the means, right? I got the mean of the means, right? And then I got and you'll see these written different ways, and one of the things they introduce you to in chapter 8 is what we call the standard error of the mean, which is really, and it could be written either one of these ways. You can see it written sometimes like this. And this is one of the issues that you have with statistics. You could look at different books, they write the same thing differently. But really, they're just saying the mean standard deviations, right? This is the mean of the mean. This is the mean of the sample means. So don't get hung up on these nomenclature and all this kind of stuff, because it's really means all the same thing. Okay, so let me say, I'm going to use an example. I have a young lady that's on the golf team here at RSU, in my on-campus class, and she said we were talking about this, and so she says, well, I know what the golf scores are of each of the golfers on the golf team, and maybe she's interested in college level golfers, right? College level people on golf teams at the universities, okay? So that could be her population. And her sample is going to be the golf team here at RSU. Now, is that a good representative sample? I don't know, but it's good enough to do for her research to get her through this class, right? So let's say she has freshman, sophomore, junior, senior, and so each one of these is a group of people, and if she took the scores for each one of these people, or these groups, I should say, she's going to have a mean and a standard deviation of each one of those groups, right? So now she's going to come and she's going to say, well, I'm going to have and typically the way you're going to do research generally is you're going to have a research question. And then you're going to have your hypothesis is the answer to that question. So first of all, you'd say, what is my question? My question is there differences between class levels among college golf team members, right? So that would be, that's my question. Are there differences between these? Okay. Now, the problem that we have here is on your sheet, it says we want N of 30. Ideally, you want 30 people to represent what we could be. And the reason why you want 30 is because that's what's been determined is a representation of the population. Okay, so if I'm interested in college level golfers, then I'm going to need to have enough of them. Now, maybe there's hundreds of thousands of these people around the United States or the world, and only 30 is not really going to be representative. But we're not really concerned about that right now. We're just concerned about doing this project. Now, the problem that she has is we want to have as close to 30 as we can here. Unfortunately, we know at RSU, there's only 18 golfers in total, male and female. And so I told her, I said, well, what we need to do is divide this in half and say, okay, well, we've got the lower classmen and we have the upperclassmen. And now what we're going to do is we're going to divide that into two groups. And instead of maybe having, 5 here and 2 here and 7 here and, whatever, 8 here, and I'm making those numbers up right. But now we're going to have, maybe we're going to have 8 here and 10 here. So we're going to have closer to the same number of people in each group. That's our goal. So whether you have 20 people or you have 100 people, if you have 4 groups and you have 100 people, ideally you want 25 in each group. Now, is that possible? Probably not. And that's okay. It doesn't have to be exact. But however, if you were going back to this scenario where I have 4 groups, and maybe I have only 1 senior, and I have 15, what do I got here? I got 18, so I got like this. If I have this, I have 15 freshmen and 1 sophomore, 1 junior, and 1 senior, that's not going to give me good results. We want to have somewhat of an equal number in each group, right? Okay, so this would be 20, but you get the picture. So, because we only have 18 people, we might want to divide this into 2 groups. Now, I'm going to tell you, whatever it is you're studying, it's going to be easier if you only have 2 groups. If you have multiple groups, like 4, you can have as many as you want. But the statistical analysis, which we'll learn as we go on through the course, gets a little more complex the more groups you have. So for all practical purposes, 2 groups is the best for what we're doing here, right? So we've got a mean and a standard deviation of 2 groups, and we have a research question, are they different? So what that looks like is the mean of the lower classmen not equal to the mean of the upperclassmen, right? That is my what we call the hypothesis. My hypothesis is that these 2 groups of people are different. Now we could say that I believe that the upperclassmen are better at golf, and this is kind of a confusing because better means lower score, right? I'm writing, are they better? Are they greater than better in golfing, which means it's a lower score? Don't worry about that because that's going to come out in when we get to the part where we're identifying what the numbers mean. In other words, you're going to say better golfers means lower score. You know, you got good teeth or bad teeth. Lower cavities means you got good teeth, right? So it doesn't matter. We're just trying to say in this case that my hypothesis could be that upperclassmen are better golfers or greater than golfers than or greater than or equal to the lower classmen, right? Okay, so this would be what you're going to study. Now, you're going to have a number. This is where I'm going. We have two groups of people, upperclassmen and lowerclassmen, and those are nominal data. But that's okay. As long as this number, I can calculate a mean. This needs to be interval or ratio, right? I need a standard deviation and a mean for each of my groups. So whatever it is you're studying, it could be boys against girls. I have a girl that's doing one. Her mother's a school teacher in the 3rd grade, and she says, well, I'm going to study. And again, this is real simple stuff. It's not big science. It's just to get you the concept of how this stuff works. That's what the project's about. And so, in other words, one of her things is her mom's a 3rd grade school teacher. She's going to ask the kids if they like chocolate ice cream or vanilla ice cream better. Now, if we said, let me do that. If I said that the choice of chocolate and their chocolate and vanilla are different, or they like chocolate better than vanilla, and how am I going to measure that? So if I say, well, do you like chocolate or better than vanilla? And they say yes, that's what you're going to get. You're going to get a yes or no, and that's nominal data. So that's not going to work, right? We need to have a number here. We need to have a number I can calculate. So what I told her to do for her research, and be thinking about what you're going to do, you want to make it easy on yourself, okay? If you want to do something complicated, we can do that later. But for now, focus on something that's simple, just so we can do the calculations in the numbers and you can gather your numbers. So I told her, I says, here's what you do. You ask them to do it on a scale from 1 to 10, right? And then maybe you're going to do the boys and the girls, right? So here's my groups. 3rd grade boys, 3rd grade girls, scale to 1 to 10, right? Whether they like chocolate or vanilla better, or they do one of each, right? So on a scale from 1 to 10, how do I like chocolate and how do I like vanilla? And I could do that as a whole class and make these two my nominal, and that's my measurement. Or I could do boys against girls. You could do one grade, you could do 3rd grade versus 5th grade, whatever you want to do. You can have the different groups, but really this is the key here. I've got to have, so in other words, in this case, let's just take this one. I've divided it boys. I've done now again, this is not a survey class. You can do a survey. That's perfectly fine. You probably, you can develop a survey. I'll do a video later on about how to do that in SurveyMonkey or one of the online programs. It's free. You can send it out on social media or by email. It's great to do that. And then you can use what we call a Likert score or something like this from a scale to 1 to 10. This is going to be your best case scenario because you might have, say I had this one, a chocolate, I got a mean of 8, and on vanilla boys, I got a mean of 5. And on girls, I got a mean of chocolate equal to 10, and I got a mean vanilla of girls equal to 4. right? And so what we could do now, we have all kinds of stuff we can study. We can study the boys against the girls on chocolate, or the boys against the girls on vanilla, or we could just take all the students, chocolate versus vanilla, and calculating the total mean of chocolate and the total mean of vanilla, right? So we got a lot of things we could do with this data, and this is just a real simple thing, but the most important thing is you can't have a yes or no. Do you like chocolate better than vanilla? Yes. Okay, forget it. We can't calculate that. We need something we can calculate. All right. So I really hope that helps you, and I want you to be thinking about it. If you can narrow it down to 2 groups, that's going to be best case scenario. If you want 4 groups, that's fine. There's a different statistical test that you do for more than 2 groups, and we'll be covering that in latter chapters. And that's where we're headed. So I wanted to do this video. I know I've ran 20 minutes, and I talked quite a little bit more about sampling distributions and stuff than maybe I should have here. But remember, if at all possible, you want more than total 30 responses. So if you have boys and girls, 15 of each. If you have 12 of one and 10 of the other, that's going to be fine. It's going to be okay. It's about learning how to do the process, not making some kind of research document you're going to print in a journal about whether or not the 3rd graders like chocolate or vanilla better. It's the idea that you go through this process, right? So I hope that helps you be thinking about it. And then what I would like you to do, and probably what I'm going to do, is I'm going to put it on the MyRSU, and I'll put a forum type post where you can go in there, and I'm going to put it down. I'm going to do this for Module 3, which is a module we're in right now. I'm going to put it in there because I want you to tell me what it is you want to study. And then that way I can help you whether or not it's going to be a measurement, or whether it's going to be feasible or not. Now, the other thing is I'm going to ask you, how are you going to measure this, right? And you say, well, I got a scale from 1 to 10. But that's great. Yeah, I got golf scores, or I got points in the basketball game. Anything where you got a number like that we can calculate, and we can divide these people into different groups. If you can get data that's already available, like the basketball scores of individual players, or the golf scores, those kinds of things are great. If you want to do a survey, now I can talk a little bit in another video about Likert scale survey. Those are the surveys where you've all taken, where it says, Likert is disagree, strongly agree, that kind of thing, right? Where you have neutral, agree, strongly agree. Now those are okay. We can calculate that, and I guess I'll go ahead and talk about it right now as long as we're doing it. If you're not going to do Likert, you don't have to watch any more of the video. But let's just say I'm going to go. I'm going to do neutral. I'm going to strongly or agree. Let me do this. Agree and strongly agree, and disagree and strongly disagree. And so what I've got is I've got 1, 2, 3, 4, 5, and now, and by the way, you're going to need more than one question. You can't just have one question, because what you're going to do is you're going to create the mean of whatever this measures. Typically on your survey, you're going to have a whole bunch of questions, and that survey answers is, do you like the food at the cafeteria or whatever, right? And they'll ask you questions about, I like the salad, I like the hamburgers or whatever. But all of that measures how much you like the food. And I'm using that as an example. It could be anything. Do you like something, or how do you feel about something? And you have multiple questions. And again, this is not a survey class because there's a whole science to putting together that. The idea is if you want to do a Likert scale, you can do that because we can convert these we can convert these here to numbers, and then I can calculate. So let's just say I had all that, and I had a mean score of 4 and a mean score of, on one group, group 1, whoever that is, and I got a group of 2.5 on group 2, right? Right, I can do that. And now I can see, is there a difference between the groups? Now, I haven't talked about correlational data. This is all about finding differences. And we haven't talked a whole lot in the course. You may get introduced to it, correlation in one of the early chapters real briefly. But I'm not going to really focus on correlational data. You can do that. It's going to be a little more difficult because it's thought different. Now, correlational data is data that is relationship. In other words, you have 2 scores. So you'd have 2 scores and see if they correlate. And let me give you an example of that. We can do that. Hours a day of practice. Scores in the game. Actual game, not a practice game. Right? Now we have the basketball players. 1, 2, 3, 4, 5, etc. And we have their average hours over, say, a month. 30 days average, the average hours is 2.4. Average 1.8. Average 2.7. Average 1.5. Right, and again, standard deviation. Then we have the score in the game. Now I'm going to have average score in the game for this person, right? This individual person. These are individual people, right? And then we're going to have the score. The average is 10 points, and this one is 6 points, and this one is 18 points, right? And this one is, I don't know, let's just do a good one, 24 points, right? And he only practices 1.5 hours. And this is just he or she. This is just an example. So what you do is you correlate these numbers and a correlational, don't worry about that right now. We're going to get to the math on all these different things I'm talking about. You could do this, where you're taking this, and then you're going to see, is there a relationship? In other words, your hypothesis is, well, I think my hypothesis is the more hours you practice, the better you score in the game, right? And that's what you're testing by doing correlational data. And we can do that. It's just a whole different process, and we don't really get to that idea, I don't think, until late into the course. But if you want to do something like that, that's fine. I encourage you to go with finding differences between means, because that's going to be the most easiest thing to do. Okay, so I've actually gone to almost 30 minutes now. I didn't anticipate doing that, but anyway. I'll put the form up, go in the form, and put in there what it is you think you want to study. You're going to want to know the population. That's what you need to put, and I'll give you some instructions on that to put in there, because I need you to put in the population, what it is you're trying to study, and how are you going to measure that, and I'll give you some feedback. So thank you very much. This is going to be your final project for the course. Start working on it right away. Don't wait until the last 2 weeks, because this is going to take longer than that. Okay, thank you.